Okay, can we start this? Start? Can we start?
Yes.
Okay. Is it clear? Video, audio is clear from my side?
Yes, correctly.
Okay. Okay. So we'll start. So let other members they slowly join. Many members still join, and will be they can easily join using the link. And in the meantime, I will just introduce about IPQC. It's a fantastic opportunity to introduce IPQC platform to all the audience here. And we are having a very important people, experts in aerospace and engineering background. One is Mr. Surendran, and second, our guest, very important guest, is Mr. Venugopal. These two gentlemen accepted, and they are ready to share the knowledge with the companies, especially aerospace. And objective is basically to bring this standard. APQP is a very popular standard used in auto industry basically, and the same similar standard is adopted in aerospace also. So more stringent norms required in aerospace. IPQC is always, trying to bridge this gap. IPQC is a professional consulting group. We are focusing more on management related areas, and we are very senior people are associated with us, and more than almost 3 decades in average experience all over senior people. More than 3 decades of experience people are with us associated in various industries. One is aerospace, engineering, and even food processing, logistics, IT, AI, and to name any thing, we are trying to collaborate and bring those experts to SMEs. We focus across the country. MSMEs is our focus area. So handhold them, basically trying to help those SMEs across the country in various areas, including engineering and auto space also. So now, recent Make in India is the government of India initiative. A lot of focus on basically Make in India. They are focusing. So there are a lot of opportunities for engineering component manufacturers to get into aerospace. So this is the opportunity where we want to help SMEs. Many SMEs, they are readily they want to become a suppliers to these big companies. But the standards and quality standards and those critical criteria they need to meet to become a suppliers to those OEMs. So to help them, we are trying to rope in many experts from this this type of webinars, and we are lucky to have these two experts from aerospace industry, and one is Mr. Surendran, and he had almost more than 3 decades of experience, and he worked in various companies across the world, and even in Canada he worked, and even in India he worked in many aerospace related companies, and he had a very brief experience in a big Boeing companies, aerospace companies also. So he is going to cover the APQP process now. After that, Mr. Venugopal is also pioneer in aerospace, and he had a BTech from NIT. Basically, he's mechanical specialization he has done in 68, and then he has done MTech, MTech equivalent program from ASC Bangalore, aerospace specialized. So he had a fantastic experience, education background, and he worked in almost more than 3 decades in HAL, and HAL is a government company, well-established company in India. And he had, after that, he worked almost more than 10 years in international consulting organization. First, so with this brief background, I request Mr. Surendran to, initiate the presentation. Please go ahead, sir, please. After that, after this presentation, I will be having a panel discussion. People can ask questions directly to these panel members. So we are very happy to answer those questions, and then we'll be having a plan, roadmap for you next things what we are going to do. Probably we can come up with a workshop something for the people who are really interested in that project. Please go ahead, sir.
Thank you, Mr. Raju, and thank you all participants for participating in this webinar. So today our subject today is APQP for aerospace, and let me set up slideshow. Yes. Our subject today is APQP for aerospace and automobile sectors. And the purpose of this program is to create awareness as well as to make the NPD team and the MSME owners to be prepared for facing the challenges in the new product development. So who should attend this program? The MSME owners, the quality personnel, and aerospace, aeronautical, automobile, mechanical engineers, and startup entrepreneurs should be attending this program. About me, I was in this sector for almost 3 decades, and I spent my time in different segments of the aerospace domain, MRO, the manufacturing, quality engineering, and tech pub. You can contact me for any mentorship in the times to come. My number is given here as well as in this. So if you look at, if any one of you had been to the air show in Bangalore, you can see India is emerging as a major hub. The industry majors are looking at India as a major supply chain hub, and there's no dearth of orders. But the aerospace industry is unique in its quality and regulatory requirements. So the orders, there are no dearth of orders, but to execute the orders, it has to go through a very stringent process, which is called APQP. This is why we are all here. And in this session, we'll try to understand what is a roadmap from the designing stage to the MRO stage. So this scope of this session, this may run almost an hour or so, and we will take you through the 5 phases of the APQP, the PPAP elements, and aligning of the PPAP elements with the APQP, and a case study. So before going ahead with the core program of APQP, let's try to understand what is the life cycle of a product, whether it's aerospace product or automobile. So there are ISO defines product life cycle in 6 stages. The stages of design, development, production, use, support, and disposal. But
sir, share the slides, sir. PPT mode it is. PPT mode, presentation mode. Is that can you make the adjustment?
Yeah, it is shared actually.
Okay, so the
PPT
presentation.
mode, can you see the PPT, sir?
No, we can still, you can.
Only first slide.
Only first slide?
Only first slide we are seeing.
That bottom, you can click that slide show. See whether.
Okay, Let me mute the video and
You can, go to the PPT mode and the presentation mode. So the slide, entire screen will be one slide. Yeah, now it is done. Please go ahead. Whatever you see the screen, sir, we also can see the same screen.
now can you see, sir?
Yeah, now life cycle of the product.
Yeah.
We are seeing. Yeah. Please go ahead. And when you change the thing, you should see the same. Whatever you see, we are also can see the same.
Yes.
Please go ahead. Yeah.
Some glitch happens. We'll move to this one.
Let me see. You can see this.
You can use the next option, sir. There also you can change the screen. Next option, and when you drop down menu comes there, you can use the next option. Make a full screen, sir. Full screen. Yeah, please go ahead. Next option is
Yeah.
there. So when you go to the next, you can go to the next slide.
Yeah.
Please go ahead, sir.
Yeah, okay.
Next schedule.
Right click, you will get a next option.
Yes.
Right. Next option there on the top.
Yeah.
Yeah.
Next option.
Are you seeing the second one?
Yeah, second slide. Please go ahead now.
Yeah.
Yeah, fourth slide. Now,
Yeah. You're in the
this one.
product life cycle.
Yeah, correct.
So sorry for the interruption. We'll continue from here.
Yeah, please go ahead.
So the product life cycle is in 7 phases, and from concept development to the product decommissioning. So are we seeing the quality management systems or no? Next slide.
We are seeing QMS.
Yeah. So before going to APQP, we will quickly understand the quality management system and the quality standards. So quality management system that we adopt is for aerospace is QMS AS 9100, and the quality standard for APQP is 9145. So we'll quickly understand this AS 9145. It is for the new product development created by IAQG. And there are similar standards. Are you able to see, sir, the AS 9102 and 03, etc.?
Yeah, we can see. Please go ahead.
Yeah. So these are some of the other standards that is working in tandem, working in collaboration with the AS 9145. And we'll take the a synopsis of what we have discussed now. The QMS exists in all sectors, and the product life cycle we have just discussed. The quality standards cover certain areas depending on where your company's activity is with. And the standard AS 9145 focus on the NPD of aerospace part. Standard AS 9145 is included in the section 8 of the QMS. The QMS is the larger canvas. And if you happen to look at the section 8 of the QMS, you can see the AS 9145 there. Standard AS 9145 rolls out the NPD process named APQP. Now, let's go to the APQP, what it means and what is PPAP. APQP and PPAP are two core tools that cover the most of the product life cycle of an aerospace or automobile part. The reason why elaborate training is given to the personnel involved in the new product development. APQP outlines the complete process to the supplier and to make sure that the supplier is capable of designing a product and manufacturing it to meet the customer requirements. PPAP is documentary evidence that demonstrates that the supplier has the potential to produce parts that consistently meet all requirements at the customer demand rate. What's the customer demand rate? A product has to be supplied at a certain quantity at a certain time. So it's not enough that you produce a part, but the customer would need the part to be supplied at the customer demand rate. To understand the NPD process better, we'll introduce a case study here. Can you see this part? This part looks like a blades assembled on a disc. In fact, it is called a blisk. A blisk is bladed disc. It's an innovation in the design of a compressor. Previously, all the blades were assembled around a disc, and now it is made in a single monolithic design, and it's working very well in the modern aircrafts. So this case study I have just shown you. So we will be virtually processing this part throughout this session. So it'll help to understand the process better. So we are in the 5 phases of the APQP. Is it visible? The 5 phases, sir?
Yeah, visible, sir. Please go ahead.
Yeah, just to make sure. Yeah. So APQP is in 5 phases. The planning phase, product design and development, process design and development, product and process validation, ongoing production. In the planning phase, one need to identify all the project scope, and it's just that not enough to just make the plan vaguely, but we need to figure out a robust planning. We need to understand each and every element and make sure that this is having a written criteria which will be revisited after finishing the project. In detail, what are the activities? We will be discussing each phase in each slide so that you can understand it later. Later, we will give only an outline right now. This slide shows the 5 phases, how they are concurrently engineered. You can see that the phase 2 is overlapping with the phase 1, planning, and phase 3 is also overlapping. Why is this overlapping? How do you avoid redundancy in time and make this happen in the most fastest track? This is why this is important. I would advise those who are learning this, please try to put it in a paper, save it, and see how time can be saved, how you can concurrently engineer 2 phases together. So we have discussed the larger canvas, that is APQP, and we also know that PPAP is documentary evidence. So what are those elements of PPAP? What are the PPAP PPAP will be discussing separately because it's a little bit in-depth and complicated. So we'll just outline them now and we'll move ahead and come back to this at the appropriate time. So design records, design risk analysis, process flow diagram, process PFMEA, control plan, packaging, MSA, initial process studies, first article inspection and customer PPAP requirements, and the PPAP approval form. These are the documentary evidences that is required. Now, these are 11 PPAP elements we have listed now, but this is not all. Some engine makers, you won't be surprised if they ask for up to 17 or up to 21 PPAP elements, PPAP forms to be signed up. So we will discuss them. Same PPAP elements, I just drawn it in a APQP canvas. If you look at this, the green and yellow color is PPAP documentation. It's interesting to see that the PPAP documentation evidence presentation is not starting in the planning stage. It doesn't mean that it should not be recorded. It will be recorded for your own reference, but the customer will ask the PPAP document from the phase 2 onwards. And you can see that in the phase 5, before phase 5, PPAP approval form is completed. What does that mean? It means the customer is not going to allow you to do any ongoing production before PPAP is approved. So it is not always that the PPAP is approved all the time. PPAP may be partially approved or even rejected. In such case, you need to go back and make sure that all the anomalies are completed and to the customer satisfaction. Here, those who are very enthusiastic about engines and aircraft would have definitely witnessed this XWB engine. This is where our case study part is sitting. Let's see where is it sitting. You can see the Bliss technology is applied very brilliantly by Rolls-Royce in the IPC compressor section. All these were individual blades in the previous design. Now it's integral part. So you avoid the task of fitting each part and take the risk of fixing them. You can imagine a loose blade coming out through the exhaust. What can happen to the aircraft? So these are now integral parts thanks to the technology. So we have seen this case study part and we know where it is sitting. Let's take it out from the engine and have a closer look. These are bolt holes. What is this for? To fit one bliss to another one. And what is going inside this bolt? Some mid shaft and seals here. You have a very preliminary drawing which is required for the processing in the planning stage. So we are going to the phase one of the planning phase. For any phase, any cross-function team needs some inputs. What are those inputs? You need the product and process benchmarks. You need product and process assumptions. You need reliability studies, the quantified number of the reliability. And of course, it goes without saying that the reliability of the product has to be better in the next level, next product is initiated. And also, customer will have some inputs to share because customer is in the business for some time and now he would have learned from lessons and he will have some input to share. So with all this data in hand, we are moving to phase one, that is planning. What are the activities in the planning? Basically, collect all the technical and non-technical requirements. Technical requirements are requirements like dimensional limits, specifications, GD&T standards, surface treatments, material specifications, NDT requirements, and if there are any special requirements from the customer. Customer can give any special requirements like surface finish, etc. Or uniformity in corner brakes. Customer can add up some requirements. The non-technical requirements are basically some commercial, like who would be responsible for transporting the part to the customer sites? What are the demand rates? And the penalties if sufficient number of parts are not delivered in time, and the timelines, etc. Developing a statement of work. Developing a statement of work is required. That's a communication tool that will go a long way in understanding the project very well by both the stakeholders. A product breakdown structure, which is a high-level bill of material. This is also required to be understood by the planning stage. After having these activities done, you need to deliver. What are those things that is deliver? You're not delivering the actual part, but deliver the targets. You need to fix the targets. What are the targets? Targets of safety, quality, manufacturability, service life, reliability, durability, availability, maintainability, schedule, and cost. All these have to be put in numbers and kept as a record. Why? Because it will be revisited after the project is completed. So means you can't just plan and say we have planned it, because it has to be on record. And you need to also understand the preliminary listing of critical items and the key characteristics. So what are these words? What is statement of work? What is a bill of material? What is manufacturability? What is reliability, maintainability, durability, availability? What is the availability status in numbers of the part or engine? All these have to be explained in depth. A preliminary process flow diagram. This is not possible in a short period of time. So this will be explained in a different session called a workshop, and will be taking it up in the workshop. So once the planning phase is completed, you have to achieve some milestones, and these milestones are: you have a design goal. You don't have a design yet, but you have a design goal, and you have the reliability quantified and the quality goals quantified. Preliminary bill of material, a process flow diagram which is preliminary because all the process is not designed. So a preliminary process flow diagram has to be made, and preliminary list of special characteristics. What is a special characteristics? We'll definitely explain. And once this criteria are understood, it's called a gateway approval. It's a gating process. It is gated to the next phase. Means this is frozen. Some people call it freezed, and some people call it frozen. It's just a language, but it is freezed or frozen for the time unless some revision comes. So this phase 1 is completed. This is taking us to the phase 2 of the APQP. What are the activities in the phase 2? We start with making a drawing. Make a drawing. This is called design record. And you should not leave any details in making a drawing. Detail in the sense, dimensional specifications and whatever is pertaining to the product should be a complete definition. And now you need to do a risk analysis. You have a product in your hand and you need to know how the product is going to perform, but the product is not yet made. But how do you make the analysis? There is a tool called DFMEA, Design Risk Analysis, Design, Failure Mode, and Effect Analysis. Using this analysis tool, you can identify each and every failure modes, possible failure modes, and then what do you do? You see there are so much failure modes, and what do you do? How do you mitigate it when product is not even made? So this is done by the DFMEA team, and they know how to. So we are going to learn this in a session called workshop session, a DFMEA, how the risk priority numbers are, you're getting it, and how you're going to reduce it by mitigating the risk in the product. This will be learning. And next phase is design and manufacture, design for manufacture and assembly. If any one of you have been through Six Sigma, there is design for X. Design for X is for design for manufacture, design for assembly, design for X is for everything. Similar, in this, our context, you need design for manufacture and assembly. This is what is important for us. A product that is nicely designed and it cannot be manufactured doesn't make sense. And again, it has to be assembled without difficulty. So these are to be taken care and should be recorded. That yes, the DFMA should not be confused with the DFMEA. This is design for manufacture and assembly. Now, first one is DFMEA is failure mode analysis. This is design for manufacture and assembly. Similarly, design for maintenance, design for repair and overall. All this to be taken care while making the product. And identification of product cases, key characteristics, error proofing. Now, discussing all this in detail doesn't happen in a quick session like this. So we will be very important aspects of the product. This we will be discussing in the workshop, a 2-day workshop probably. And one more important thing in this phase is tolerance stock analysis. assembly of similar parts stocked up in a certain area of assembly, if the tolerance is not properly given, either it will end up in too loose assembly, which is very dangerous, and too tight, which can stress out in working. So this is called tolerance shock analysis. We will be discussing this in the special session. I am showing you this slide again, just to see, revisiting, and you can see phase 1 and phase 2 is overlapped, and phase 3, which we are going to look into now, that's going to start simultaneously with the product design. So this very important, probably a Gantt chart in a different way will make it very clear what are the concurrent engineering that is possible. It's not extended to the planning stage, start right there. Means that phase 3 activities can be, for example, cutting the raw material. Once the preliminary size is given, can probably start processing, cutting the raw material. For example, I'm saying it doesn't apply everywhere. Please don't take it for granted. But depending on the product, concurrent engineering can be done. So we are moving on to the phase 3. What are the activities in the phase 3? Even though we have gated the phase 2, it's not, we have to identify some areas where the phase 3 can be done, and where it doesn't apply, it should not be done. What are the main activities? Activities start with identifying the process and key characteristics. You need to identify, once you start cutting the metal, oh, did I say metal? Are you all in agreement with what I said? We are cutting the metal now. Because so many of the components are of composite material now. So I have to change to material. When you start cutting the material, you will do it in stages, and probably a roughing stage, roughing 1, roughing 2, roughing 3, finishing 1, finishing 2, and drilling and deburring, inspection, and the special processes of like NDT or short peening, and then the coating, etc., painting. So once you do these processes, you will find that some key characteristics emerges. Once you make the center board, you will know that, yes, you have a mid-shaft sitting in this bore. So it has to be very, very critical. So identified one. From this part, can you identify any other? The bolt holes. Are they very important? What if one bolt hole is smaller? It can be reworked, right? So it's not very critical. If it's bigger, of course, it's bad. But what if the outer diameter is less? If the efficiency of the engine will be reduced and the lifetime will be reduced. So that could be a critical size. If it is very difficult to make, but it's not easy, it's very easy to make the outside size. So it's not very critical that way. So you have to analyze this and identify the critical characteristics and dimensions. And like we have done the DFMEA, now we have to do the PFMEA, process failure modes. So what is the difficulty in, or the risk in making these thin blades, cutting them so deep? And what is the difficulty of making the center bore? What is the problems that you're going to face? For each critical specification or the size elements, you need to do the risk mitigation. The tool used for this is called PFMEA. So the PFMEA should be done for all critical characteristics. Not only some sizes are critical, certain features like concentricity, angularity, all this could become. Sometimes the concentricity between two bores are more critical than the size itself. So that becomes you have to identify. It comes from experience, and experienced people will be doing it. Your role is to understand, yes, this job is held up for identifying the critical sizes, and the critical sizes are maintained, identified. One more very important thing in this phase 3 is control plan, preliminary control plan, and measuring system analysis. What is measuring system analysis? The machine manufacturers are capable of making any part to any accuracy these days. If you visit the IMTMA exhibition, you can see all CNC machines are so capable of maintaining accurate dimensions consistently in a micron. A micron is 1/1000th of an mm. And cutting tool manufacturers, they are also very keen in supplying cutting tools to cut the hard materials. There is no dearth of opportunities. They are working very well. But we have discussed machine and the cutting tools. What about the measuring system? Is your measuring system capable of reading the right part good and the wrong part wrong? Is there any instance where your measuring system is not capable of reading the right measurement? For example, you have the bore size is 100.001, 100 plus 1 micron, and the basic size is 100. But how do you know that this is right measurement? The true value, nobody has seen, nobody ever know. You can only get close to the true value. So what are the problems? What are the hurdles in getting to the real value? There are a few factors: bias, linearity, stability, repeatability, and reproducibility. These are the villains that stand in the way of the inspector who is in pursuit of the truth. The truth is a true value. So we need to go in depth. So why is this required? The customer will need an MSA plan, MSA study to be conducted by the supplier. The customer will need the supplier to conduct the MSA study, without which he's not going to accept the part. So you have to make sure that your measuring system is capable. So covering this in depth will be done in a session that is called a workshop. And not only MSA, will be covering PFMEA, MSA, control plan, all this in a different session. And what are the milestones? The packaging standards. Packaging standard, the packaging is very important because once the part is made so accurately, especially if it's aluminum part, it's likely to get distorted in transportation. So packaging standards and specifications, process definitions, PRR, which we'll again discuss in detail. Process flow chart is made because now you identified all the processes. Some of the process chart, which is a diagrammatic sketch of the process flow. Floor plan is how the machines are laid out. Characteristic matrix is a communication tool. PFMEA, pre-launch control plan. MSA, and once all the preliminary process capability. What is process capability? For example, you have the size 100.001 mm, 100 plus 1 mm, 100 was the size required. It's now 100 plus 1 micron. This is the first part. And now after 2 weeks, first 10 parts, average is 100 plus 1 micron. After 2 weeks, take another 10 parts and measure them. Average size has come to 99.997. So what happens? Tolerance is 5 micron plus or minus 5 micron. You need to give some tolerance. So it's still within tolerance. Then what happens? It is shifted 4 microns to the lower side. Probably what it is fitting in a fixture, now it won't fit anymore. But you have made the size as per drawing. The customer cannot hold the payment. But there is a problem here. Capability. The process is not capable. The process is shifted and customer would blankly say you have no control over the process. The process is shifting. You have not identified what is the reason for the shift. So this is called the process capability study, which we have to, it is lots of, not lots, a little bit of mathematics into it. And the process capability we have to study and submit to the customer that the process is not shifting now. We have taken control of the process. So this is very important because if the process keeps shifting, like plus 4 microns to minus 4 micron, it covers like most of the tolerance field, right? So even though the tolerance is plus or minus 5 micron, the customer do not want you to make plus 4 micron and next 10 parts minus 10 or minus 4 micron. This is not acceptable. So there is a limit, there is a number, and that number will be calculated and that has to be studied. So this is the process capability. So once all these milestones are achieved from the phase 3, we are moving on to the phase 4. So we have all the process done and we have a first part done. Along with this is a prototype now. Along with the first part, a first article inspection, PPAP, it should be in the PPAP file, FAIR it's called. First article inspection report is to be made and it should be submitted along with the PPAP papers. And now here you have completed all the production run and collect the data here and to establish that the part is done, conduct the MSA plan. So MSA plan is made. How do you do the MSA plan? How to have a control of the capability of the machine or the measuring system? Probably you will need a calibration done up to date. Probably you need to replace the older machines. Probably you need to train the personnel. Probably you need to make sure that the training is ongoing and there is no bias among the machine as well as the personnel. So this is a conduct the MSA study and review all the results of the production runs. So corrective actions, all this you do before doing this while doing the phase 4. So phase 4, you have to get the PPAP approved. Before going to the phase 5, we have to have the PPAP approved. What if the PPAP is rejected? For what reason? If the MSA failed, okay, conduct MSA again. If the process study fails, you have to do the process capabilities again on the new part. And this time you make sure that the process is in control. You're not shifting a lot. It was okay if it was okay minus 4 micron before, and you consistently you maintain the same, probably it's okay. The problem is shifting. The shifting, you need to identify the reasons, and it's really little intriguing and it's complicated to say that, okay, it's away from the mean, it's okay. it's okay, but still you are in control of the process. This is very important. So the milestones from the phase 4. Now you started producing the part. Production run started. It could be batches. Aircraft parts cannot be like 10,000 parts like automobile, but production run is started. MSA results, you have no MSA results. Process capability studies being conducted in a regular way, right? It's just a study, just measure and make sure it's happening. There's nothing wrong here because of process capable, it's not capable, not going to reject anything, but they will give you warning. PPAP is now process is completed. Production validation is done. You need to validate. What is the production validation? It's not a product validation, it's a production validation. Means you validate that whatever is planned is being done properly. That is production validation. Packaging evaluation is done. And it should be recorded. It's a PPAP requirement. Production control plan is a live document. Again, what's the control plan? Control plan is those critical dimensions in the machining stage or whatever is the operation stage, how you control the critical sizes. What are the plans? It's not a failure mode analysis, but whatever critical items are in the failure mode is taken forward to the control plan. Some companies ask for every dimension to be in the control plan. That will become a very long document, but if the customer asks, you have to give. But normally, the critical sizes will be taken up for the control plan, and the customer would like to know dimensional control. What happens? What are the pros and cons? What happens that is a washer inside bore is bigger? What happens? It becomes too loose. If it's tight, it won't go in the bolt. Similarly, all the critical sizes. What have you understood the importance? What are the mitigation plans for making? What are your control plans? This is a control plan. There are forms which we can give you, and you can understand how to make a control plan. So once all this addressed, all these issues are addressed, we can now sign off the phase, and the gateway approval is done. Gateway approval, again, the cross-function team agrees upon by writing or by virtually or agreeing in a meeting, whatever way you approach it, you approve the gate, and means that you have frozen this phase 4 and we are moving on to the next phase, phase 5. Phase 5 activity. Now that I know some of the cross-function team, they are now relaxing mode. Well, all done. Now, as per the customer requirement, we have done the part and the PPAP is approved. What is this phase 5 now? Are you sure that the part that you have made is functional for now, but will it survive the warranty, or will it perform till the complete life cycle is completed? Will the maintenance repair overall team will complain that they can't see the reading when you assemble, or will they complain that your seals are too sharp? Instead of 20 years, it'll run maybe 2 years. So these are the activities in the phase 5, very important. And you also need to revisit the phase 1 here, and to make sure that all the criteria are met. All the criteria in the planning phase, whatever is planned is met. And now CPK, parts per million, KPIs, all on-time delivery, all are done. This is not easy. It's easy to make 10 parts or 15 parts first, and then continuously, because you're putting all your effort for the first part. But the same effort, can you continue for the demand rate? So this is why the phase 5. So that's why we are revisiting the phase 1 again to make sure that whatever is the goals they are achieved. So no quality study goes without visiting this site, this PDCA cycle. Plan, do, check, act. We have the planning stage, we have the development and verification, and we have executed the part. And now we are going to the planning stage again. There is a window of improvement here. This is why this cycle is very important. And any company, any aerospace company, the customer would need a window here where you have leapfrog to a next level of improvement, continuous improvement. Could be 5 years, could be some Kaizen or whatever. You need to show that you have taken effort to improve. You can't complain that, yes, we have done all the parts as per requirement, now what? But this is important. And it's a very classic cycle. And this is what is taking us from normal phone to the latest iPhone. This is why. So phase 1 milestones. So we have reduced the variation now. Because of all the efforts, variation is reduced now. Remember the capability study. Now the process is more stable. Improved customer satisfaction. Customers understood that you have reduced the variation. Improved delivery performance. It's very important. In fact, it's one of the reasons for the revision of the QMS that delivery was not happening. So they become lethargic after the first part is approved. So improved delivery is improved. And effective use of lessons learned, or the lessons learned in the corrective action, they are recorded and they are revisited, and lessons learned is applied to the next part. So those who want to attend the workshop can register by the website. And thank you very much for watching this webinar. And I'll hand over to Mr.
You
Raj.
can stop sharing the screen, sir. We can invite our other member, Mr. Venugopal. Sir, can you stop the sharing the screen, sir?
Yes, sir.
Okay. So, so now we are having a brief panel discussion, question answers. Thing is scheduled. So I request audience, the people who wants to ask a few questions, we can answer those questions. And before that, Venugopal sir is I already explained, we had a more than 3.5 decades of experience and additional 10 years of experience in various consulting entities, and globally worked, and he has worked our own entity, HAL, government enterprise, and he had a lot of experience, vendor development and other things. I request him to share his, basically the, problems, issues related to vendors in India, how they can, basically overcome those things. He may be having a lot of, exposure to those areas. Please go ahead, sir. You can unmute and speak, sir.
Yeah. Thank you, Mr. Raju. I think you had a very interesting talk by Mr. Surendran on the pros of APQP and the PPAP and all that. I'm not going to present anything. I'll just talk off the cuff. Okay. The aviation industry. Okay. Why? What is the purpose of this the webinar? That is to give you some idea about the process of achieving quality and how to maintain quality and all that. So where is the need for all this? So that's what I'm going to talk. The aviation industry in India is poised for a big leap. We had a temporary setback because of the COVID for about 2 to 3 years. The air traffic also suffered because of that. but now it's back to almost normal. I think we have reached something like 97% of the um, passenger traffic before COVID. And India is now the third largest domestic aviation market. And strangely, you know that we behind the US and China. And very interestingly, another small country is also in the top 5. Can anyone guess? It is not UK, it is not France, it is Ireland. So I was myself surprised how Ireland, such a small, tiny country, is figuring in the top 5 aviation in terms of passenger traffic. Okay, and the government recently, you know that traditionally there were very few aircraft manufacturing industries. In fact, there was only one. It was a HAL, Hindustan Aeronautics Limited. But initially we were looking mostly at military aircraft. There were a few aircraft, passenger aircraft, which was manufactured by Hindustan Aeronautics Limited. One was the HS-748 Avro. Another was the Dornier 200. So these two aircraft are the only ones. And then National Aerospace Laboratories, they tried to develop an aircraft called SARAS. But it has not been produced in large numbers. It was mostly at a prototype level. However, now the government has taken a very bold step to increase the aircraft production, aircraft related products in India by Make in India program and other things. So I think it is poised for a great growth. So the projection is that it will be something like 70 billion US dollars by 2030. That is a projection. So it's a very, very large. At present, maybe something like, I think totally it could be about 10 or 20 billion, but that's going to be 70 billion. And the exports will also be something like 5 billion, US 5 billion by 2025. These are the projected figures. So in this, what are the major things? One is that the airports themselves are going to, the number of operational airports are increasing. From 74, it has now reached about 140. And they want to have 220 operational airport in the next 5 years. So all the related things, including infrastructure, even civil infrastructure, all that will have a great scope for growth. And then many of the private players have come into the aerospace field, as you may be aware. Tatas have come in a big way. They are supporting Sikorsky, Boeing, and Airbus and all that. And then there are other companies like Adani supported organization is there. And then Mahindra has also jumped into the bay. And it is expected that all this will really shift the aircraft manufacturing in a big way to India because of the trouble people have with China, where many of the aircraft used to be manufactured and assembled. Now, I think it will slowly shift to India, and some of the major programs like the F-16, the Lockheed Martin, they are trying in a big way to establish the facilities in India. And then even the they want to supply even to the Air Force. Of course, they have not won the contract yet. That there is a possibility that 114 aircraft which India is trying to procure, it might go to Gripen, that is Swedish. But then these people are trying to collaborate with the Swedish firm, that is Lockheed Martin. So that's another opportunity. And then we have a Dynamatic Technology who are supplying a lot of components and structures to Airbus, then Sukhoi, even for the LCA Tejas. They are the Sukhoi and LCA are indigenous. Sukhoi is under license. However, LCA Tejas is a purely indigenous aircraft. And we have a number of helicopter programs like the Advanced Light Helicopter, the Light Utility Helicopter, and medium range helicopter, which is going to be developed. So I think the sky will be the limit. So all this will require And the government is also expecting the private players to lead. I mean, to take a huge burden of these projects. Now, the process till now, it has been a little bit, I would say it has been a little bit tedious as far as HAL is concerned for the projects like Tejas or the helicopter projects. There were a lot of bureaucratic hurdles, but they are now being reduced to a large extent. And one of the major achievements of the light combat aircraft, that is the Tejas program, was that many private players contributed to that project in developing systems, in manufacturing structures and things like that. And this is only going to grow. So these are some of my thoughts on the scope and the future. And right now, the process in HAL for subcontracting, the HAL subcontracts some of the indigenization of the imported equipment. Second thing is the manufacture of the parts and system which are designed by HAL. And then there could be just routine outsourcing of products. So in this, you have to register the companies, SMEs, MSMEs, they have to register with HAL by filling up some forms, giving details like the capacity, how many machines, what is the spare capacity available, and the accuracy and all that. There is a format which has to be filled, and with a small amount of 100 rupees DD, you have to submit it to HAL. Then they will come and visit the facility. A team from HAL will visit that, and then they will assess whether whatever is told is correct, and then HAL can utilize the facilities available with those subcontractors. Once that is done, then of course it is straight away. Once the capability is finalized, it is verified, then you will get a formal inquiry for manufacture of components, and then of course it will go by the economics. That is a cheapest quote will, of course, they will get the order. That is how it is. As far as a development of either a new system or a replacement system is concerned, it is slightly more complicated. Again, the capabilities will have to be assessed, and once you do that, based on the specification, you will have to make a plan how you are going to manufacture. And then the certification authorities, there are certification authorities for military aircraft, which is CEMILAC, Center for Military, Center for Military Airworthiness and Certification, CEMILAC. And then if it is a civil item, the DGCA, Director General of Civil Aviation, they will be also involved in the development, and they will also be involved in the assessment of your facility. And then later, during the actual certification, you'll have to do a number of tests to prove that, to validate the system, for which you'll have to use the facilities available at HAL and other laboratories like CPRI, the Central Power Research Institute, and DQAL and CQAL and things like that. There are a number of government facilities where the testing can be done at a very nominal cost. So then you'll have to go through that, and then you are issued a type certificate. That means the firm, whoever has developed, he is given a type certificate for making that product, and then that can be supplied to HAL as per the demand by HAL. So this is the process for development of a system. Other one is for outsourcing of components. Yeah, so that's what I just wanted to give an overview. If there are specific doubts, I can try to answer them.
Great, sir. So there may be some questions. We'll take up the questions. If anybody need thing, please raise your hand, and you can speak. We'll allow you to speak. Any audience, any questions, you can ask directly the panel members. Anything related to APQP process, anything related to HAL process. There may be many of these things, whatever is mentioned about the experts. Probably there are a lot of things, similarities. So anybody attempting to become a vendor to these companies, please go ahead and ask. I'm just, yeah, please go ahead and ask. Is Mr. Devendra, you want to ask some question? Hello, you
You
can
have to
unmute.
unmute. I think his mic is muted. I think you have
Unmute,
to.
unmute and ask. If anything,
Yeah.
yeah, please go ahead. Please go ahead. You unmuted. You can speak now. Hello. Or you can write your things. We'll take up that question answers. Q&A, things you can write about it. Okay. Any other questions? So we can probably what we do is probably there may be a technical issue. What we will do, we'll collect all the their questions in the form of a written thing. We'll give it to you people, and they can respond even in later stage also, not an issue. And they will be, they can reach out. They can write to us anytime if they need any help, any support. We can help you and people, and we were planning some workshop, and probably Mr. Surendran can can highlight that. So please go ahead, Devendra, Mr. Devendra, please go ahead. Can you hear me? Can you hear me, Mr. Devendra? Your audio is we are not getting your audio. You can go ahead. You can speak. We are allowing you. You need to increase the volume probably. You check your probably the system there. You can speak and you can ask question, anything, or you can write in a Q&A. I will read out for you. Yeah, there is a question. How to become a qualified system auditor? The question from Madhav Borwankar. Sir, can you hear me, sir? Can you both can hear us? My question, I am reading out. There are two questions. One is question how to become a qualified system auditor in a probably in APQP process. And there is one more question, Mr. Devendra. Can you share the presentation? We will be sharing some of the clippings, and after getting the permission from the speakers, I will be doing that. So presentation, no, in the video form, we'll be sharing the critical in the video form, whatever presentation is there, we'll be sharing. And yeah, these are the some of the question. And there is one more question. We are working on a modeling and a simulation platform for the aerospace and defense. Is a question from Naga Rameshwar. So please guide us how to work with the HAL for the system integration purpose. This is the question from Naga Rameshwar. Sir, you can, if you want to take up this one, you can help them to, basically answer this question. Once again, I will read for your.
No, I am seeing that. No problem.
Yeah,
we are working on modeling and simulation platform for aerospace and defense. How to work with HAL for system integration purpose. So we have to check up whether there is a, whether HAL is looking for such a system integration help, because unless they send out some, put out some advertisement saying that we are looking for people for system integration, it may not be, you may not be able to do much about it. So I can, with my contacts, I can find out whether they have any requirements, and probably I can let you know. That's all I get.
Fantastic.
Yeah.
Okay.
Whereas for the outsourcing, there is a separate outsourcing department in each of the divisions. For example, the Bangalore itself, there are 2-3 major divisions like aircraft, helicopter, and engines. Similarly, you got in Nasik, you got MiG, and then related other Russian aircraft. Okay, so those people, they all follow the same process. So there are the DGM outsourcing or chief manager outsourcing. You can contact them, and then they will tell you the procedure for registering. But I can probably find out whether there is any requirement for system integration. Though I am not so much in touch with HAL nowadays because I have retired almost 12, 13 years back, or 16 years back. Okay.
So fantastic, sir. I will definitely will be helping them. And yeah, it's very nice. You made a thing like see, there is APQP process driven by the international standards, and there is HAL their own because of government entity and government defines the rules, and there are a lot of conflicting things. Their own security point of view, there may be stringent norms. Which one is a mandatory? The APQP process helps them to become more, they can become international suppliers. Is that our defense standards? If they follow Indian defense standards, they can get the APQP process. What is your way of comparing these two?
I think Mr. Surendran can answer about the need for APQP for at least the foreign principles. In HL, I'm not sure whether, of course, see, many things will be common. The process will be it may be called differently, that's all. But I'm not very much aware about the requirement for supplying to HL. That's all.
And is there any system developed by Indian companies to develop the suppliers? Is there any standard, our own standard or defense?
No, we are depending on other standards. For example, the all the military aircraft, we follow either the MIL standard, which is by US, okay, military standards. That's what we follow. So
that is more stringent, I think. It is more stringent. Right?
Yeah, it'll be stringent because what happens is the military aircraft have to do much more than a civil aircraft in terms of maneuvering and things like that. Okay. And then for the civil, it'll be the FAR. We follow the FAR, that is Federal Aviation Regulations. So if you have to certify anything for a civil aircraft, and then DGCA will be the authority who will be certifying that. That is the Director General of Civil Aviation, who have their headquarters in Delhi. Similac, incidentally, is in Bangalore. Okay. Yeah. Oh. So these are the main standard. But then the other things are all, for example, if you want to later go to an international aircraft manufacturer, then I think whatever Mr. Surendran said will be required. And many of those things are included in our own quality management system. Okay. But it may not be actually called APQP. That's all.
Okay, fantastic. Sir, Surendran, sir, you want to say anything about thing in the future? Do you really want to engage with some of this audience for the further programs?
Yeah, well, the APQP is even when you change for example, from Penia to Devanahalli, which so many companies have done now, they will still need consider this part as a new part. Even though it has been running in Penia for a long time, once you change the location, who knows that the machine fell or something happened. So they will need a new prototype. So that's why you can see in all companies, one or two machines will be producing parts on a regular basis, and the rest will be doing new. And APQP process will be, and a set of engineers will be continuously doing control plans, changing, and so this is a bigger time, and machines and personnel are used for MSS all the time.
Okay.
Yeah, so this is why APQP is important. We have to.
Yeah, now because the clusters are coming up, aerospace clusters, so shifting from the conventional locations to these places.
Yes.
Requires a lot of documentation, lot of validation.
Lot of documentation, lots of documentation.
And
up to 90 documentation and a small washer you will be submitting.
So it's fantastic, sir. Anything you want to say about upcoming workshop in the future, near future?
Yeah, it's we can discuss in one-to-one and
Yeah, we will connect. Yeah,
different
if you
case
want to
studies.
share
Yes.
anything to outline something, you can share the.
Yeah, we will have case studies, separate case studies, and
Okay.
familiarize with the one with the authentic information, which you
Okay.
won't get anywhere else.
Oh, okay, fantastic. So hands-on experience, how to develop a product component to
Yes.
final APQP, meeting those standards. Is that a thing you want to run as in a workshop? You want to showcase that case?
Yeah.
Okay, fantastic. So, any other questions? If you have any audience, I just check any questions are there. I try to read out. Yeah, we want to integrate aircraft made by HAL. We want to integrate it. This is the same question I think we answered already. And is a question by Naga Ramesh. So the platform is a TOT, it's a South Korea. Is I think he's trying to respond to. We'll get in touch with you, or your office or offline. We want to get in touch. So we'll be sharing all the contact details, not any issue. And if anything is there, please write to us info@ipqc.in. We'll be forwarding to the experts. When they are to the workshop exclusively on cases how to bring those standards using the case study. So it's a hands-on thing. It's a fantastic opportunity. Please join the workshop, and we will be communicating to you all of you. And I thank Surendran sir for his time and a lot of time he has spent on this. And I also thank Mr. Venugopal is agreed to share his knowledge. He's having a lot of experience, exposure to these standards and requirements, defense requirements. So we really thank you for your time and valuable inputs, and we'll be continuously engaging with you, and we'll be bringing you frequently to the discussions in the coming days. Thank you so much for your time. Any
Thank
other?
Thank you, everyone.
Can we close the meeting, sir?
Yeah, thank you so much.
Thank you.
Venugopal sir.
Yeah.
Thank you for
Thanks,
providing
Mr.
the platform.
Thank you, sir.
Thank you all the participants.
Thank you once again.
Okay, sir. Thank you so much. We'll be sharing the recorded one, and we'll share the whatever is the questions asked to the people numbers. You can speak to them. Okay, sir. Thank you.